All right, so welcome to Rapid Shutdown Requirements and Solutions. This will be the Q4 update as we get ready for a major change in NEC code that'll be coming January, not too long from now, January 2019. My name is Mike Rogerson. I'm Director of Marketing here at SolarEdge. Joining me today is Jason Bobrook, our Director of Code Compliance. You want to say hi, Jason?
Hi, everyone. I noticed, Mike, you didn't get your name on the first slide, but you got it on this one.
Well, you're the main speaker, so we'll let you do most of the speaking today.
Glad to be here again.
So Jason will be helping us navigate all of the content and be available at the end for Q&A. Our agenda today, we'll kind of jump through a couple things. NEC evolution, how is NEC changing? Specifically, we're going to dive into NEC 2014, NEC 2017, and then the changes for NEC 2017 that are coming up in January. We're going to talk about rapid shutdown with SolarEdge. What does our solution look like, and how does that solve the NEC code compliance rapid shutdown portions for you? We're going to dive in a little bit into our commercial solution. Because we have two modules per every optimizer, there is a wrinkle in the commercial solution that you need to be aware of. There's certain optimizers that you need to pick over others. We're going to go into some lessons learned that Jason has been on the forefront of this for years now, and so he's picked up a couple things that the inspectors are looking for, and we'll run through that, and then we'll run through your questions at the end.
Okay, so we're going to talk a little bit about the evolution of the NEC code as it relates to rapid shutdown. I'm not going to try to cover the entire evolution of the code. It's started way before my time. But as far as rapid shutdown goes, the NEC adopted provisions for rapid shutdown in 2014, in the 2014 code. The reason for that was essentially the PV industry has grown very rapidly over the past 5-10 years, and so there's more and more systems really on residential homes was kind of the scope of it, but as well on commercial buildings now. So what you have is a growing number of PV systems on structures. Those systems may take up somewhere between 50 to 80% of the roof area, depending on how aggressive you are with your layout. This really just presents a new obstacle for the firefighters. There's different regions of the country have different operating procedures, but in general, firefighters are trained to climb up on the roof and ventilate the structure. And so how does this work? They can create an opening in the roof, either using an axe or a chainsaw or some other tool that lets the hot gases out and the smoke, which can control how the fire is behaving internally, or it can also provide fresh air for any occupants that may be in that zone that's needed to keep them conscious, so to speak. There are other ventilation techniques. So structure can be ventilated on a wall, high up on a wall. Windows can be used for ventilation, but one of the basic techniques is ventilating from the top of the roof. So I made a diagram here to kind of show what a typical rooftop looks like. This is for residential, but the same logic applies to a commercial rooftop. The new obstacle on the roof, which is the PV array, there's two things going on there. It presents a new physical barrier. Now you've got this, thin structure that's over the roof surface. What do? Do you kind of move that out of the way? Do you work around it? Do you cut through it? There's a mechanical thing going on there. There's also an electrical concern, and that's the big thing, right? Not only do you have this physical barrier now above the roof surface, but you've got a physical barrier that's electrified when the sun is shining, with a lot of conductors running underneath it. Some may be in conduit, some maybe not in conduit. The roof may be penetrated underneath it. There could be conductors just under the roofing structure, against the roof deck or just below the roof deck. So it's really just kind of an unknown black box, if you will, to the emergency responder. And you've got to remember that most emergency responders are volunteers, and they have maybe little or no electrical training. So their training is much more around how to save lives, how to put on the protective gear, get the oxygen mask going, how to, work the fire truck, where to place the hoses and things like that. How to get in and get out fast really is what they want to do. And so when they see this kind of new thing on the roof, so what do you do? And so the reason that the rapid shutdown requirements were brought into the NEC was to provide some knowledge or some sense of, hey, now I know what's going on in this area. So this picture illustrates that. On the left, you see NEC 2014. I think we're all familiar with that code, so I'm not going to walk through it line by line, but there's a 10-foot border required around the array. And that 10-foot border essentially gives some guidance to the emergency responder that, look, everything within that border may be energized. It could be at 600 volts, could be at 1,000 volts if it's on a commercial rooftop. Everything outside of that 10-foot boundary should be de-energized once rapid shutdown is initiated. And so that's what the rest of the diagram shows. You can also see the conductors, inside the roof structure. You have about 5 feet of conductor allowance. That's the length of the conductor inside the structure that could still be energized. Once you're past that 5-foot length of conductor, the energy needs to be reduced to less than 30 volts in less than 30 seconds. And so I'm trying to show here with the diagram. That really just gives the firefighter some knowledge about what's going on. So instead of it being a black box, now he knows I have a zone that has the potential for electrocution, and I have a zone that is safer and no potential for electrocution, essentially. So let's move over to the right side of the page now. What's different about NEC 2017? So the same logic applies in 2017. Let's create, we have 2 zones still. We know what's going on in both of those zones. Essentially what's changed is that the rules for the zone that is inside the array boundary, those rules have changed. So you'll notice visually too, the boundary shrunk quite a bit. It went from 10 feet from the array boundary to 1 foot from the array boundary. And so what that does is gives a lot more roof space available for firefighters to perform their operations. So whether they want to place a ladder in that zone and climb up the roof, maybe they want to put some sort of footing into the roof. I've seen these, essentially it's a spike that you stick in the roof and you can step on it. It just lets them know that that zone will be de-energized when rapid shutdown is initiated. And then within that boundary now, the voltage must also be controlled. So this is really that's one option. That's really the biggest change in the code, is that you may have to do something within that boundary to control the voltage, or I should say control the hazard. So if you're going to control the voltage as a way of controlling the hazard, that voltage needs to be below 80 volts DC. You can also see that the length of conductor allowance inside the structure has changed, and there's a purposeful difference in this diagram. The 3 feet is no longer 3 feet worth of conductor, it's just 3 feet from the point of entry. So it's a little hemisphere there instead of a length of conductor. And then outside that zone, everything is essentially the same as it was in 2014. Less than 30 volts and less than 30 seconds. Okay, so this covers a lot of what I just said. The requirements are split into 2 zones. Specifically, 69012 B1 stays about the same. Inside the boundaries for B2, you have 3 options. And I'm going to cover those 3 options in just a second. Main thing to remember there is that in 2017, the requirements for controlled conductors apply both inside and outside of that boundary. In 2014, didn't have to worry about what was going on within that boundary. Now you do in the 2017 code. So, and the other key point is that rule takes effect on January 1st, 2019. So even though it was written into the 2017 code, an extension was given to allow the industry to provide solutions so that people could adjust and there would be products available. So the rule didn't take effect when 2017 was adopted by different regions. It actually takes effect on 2019. So this adds a little bit of confusion when people talk about 2017 code. I've heard people say things like, hey, when are people going to adopt NEC 2019? I'm like, well, there's no NEC 2019 code cycle, if you will. It also raises questions about how that's enforced. Does it just do inspectors, magically start inspecting to these rules on January 1st, or does it go by the permit date? So I'd like to see how some of that plans out. So here's the three options, and I think this is what people are very interested in. And this is actually spelled out in good detail in the code book. I've simplified it here drastically, so it's a little more complex than this, but here's essentially what you can do. You can take option number one. You can take the entire array. You can get it listed by a NERDL, or you can get it field labeled by a NERDL. And anybody who's gone through a field labeling process with, say, UL or Intertech or CSA or TV or somebody like that knows that that's not a fun process. I've had to do it a couple times myself. An engineer has to come out, evaluate the system, look at the drawings, look at the manual. He may do some quick measurement or something on site, and then he provides a serialized label from the NERDL to just that system. Right? It's expensive. It takes a lot of time. It takes some money to get folks out there. Listed is something you would do in the lab. So one way to do this, for example, would be to take an entire PV array, all the wiring components, the combiner boxes, the connectors, the racking system, if it affects the behavior of the system, et cetera. Take that whole PV array, maybe even the inverter too, set it up in a lab or set up some sample of it in a lab and have it evaluated by, say, UL or Intertech. And then you would be able to list that entire array as a listed rapid shutdown PV array, if you will. And the reason you kind of switch back and forth between using the term rapid shutdown and using the term hazard control is because there is a new standard coming out that actually spells out how to evaluate a PV system for hazard control. And so that new terminology was brought in because you could actually perform the hazard control without having to do a quote shutdown of the array. We joke about it sometimes, but it was also obvious that rapid shutdown is not always rapid, right? It can take 30 seconds according to code, and you don't always, shut down the entire array, so to speak. So you actually reduce the voltage in a lot of cases. You attenuate the voltage. And so that's how our system works. We actually attenuate the voltage on each optimizer to 1 volt DC, and we'll go over that in a moment. Okay, so that's option number one. It's doable, but it's complex, and it's new territory. The standard doesn't exist yet. It's being drafted right now. There's a lot of great work going into it. So I don't want to say anything critical about the standard at all. I think all the experts are contributing to it, and it's going quite well. I think we're learning a lot as we step through the logic, but it's just not there yet. The other way to do it is to limit the voltage within that boundary to less than 80 volts, and so that's the traditional SolarEdge rapid shutdown solution. There's other products out there that behave this way as well. There's microinverters on the market. There's other DC optimizer type solutions on the market that can do this. Those products are available today. They're off the shelf. For example, with SolarEdge, our inverters are sold with the optimizers. They're a system. They're not separate components per se that you buy from different vendors and put together. From other suppliers, there are products out there that are listed and they've been tested and listed to be used with other inverters. And so there's combinations out there that work today. That's probably the easiest path forward, I would think, in the near term. The third option, we'll talk about the third option, which is not as popular today, but it could be popular in the future, and that is no exposed conductors or metal near the array. So this is for building integrated photovoltaics, essentially. And so this was brought into the equation because there were products out there when the code was being written that didn't present a shock hazard necessarily because they were non-metallic. And so it's kind of like the bird on the wire idea, right? The bird can sit on the power wire and it doesn't get electrocuted because he's not touching ground or not touching anything else that's at a different potential. Same idea with a non-metallic PV array. And in order to keep that safety idea that you're not going to touch something grounded if you're touching the array, the distance requirement was put in there. So you can see there it's 8 feet away from grounded parts. It's actually 8 feet away from ground as well. So if you have a low roof, you You can't use option number 3, but that's option number 3. So that does allow for innovative, roof shingles and other types of architectural products to exist, and use that allowance. The products can be listed in different ways today. So you'll see 2 terms out there if you actually go and dig into the UL material or the Intertech material that's on the website. One is PVRSS, which is PV Rapid Shutdown System. The other one is PVRSE, which is PV Rapid Shutdown Equipment. The difference there is you can, I'll use SolarEdge as an example. You can take the SolarEdge system, which is the inverter and the optimizer, get both of those things listed together as a system, and you're good to go. You've got the PVRSS listing that covers everything. If you're just going to sell one of those pieces of equipment, say standalone inverter without anything else, or a standalone optimizer, or a rapid shutdown box, something like that doesn't have any other pieces of equipment associated with it from that vendor, then you would get it listed as PVRSE. And that would, there's a little bit of differences there in the way you do the listing, and essentially you just want to ensure that things are rated and they're compatible with each other if you're going for PVRSE. The first draft for doing this stuff was actually released in 2015, so it's not new. So people have been kicking around the idea of listing rapid shutdown products for quite a while. It's been getting refined, and as I just mentioned earlier, there's actually a new standard out for how to list those things, and we'll soon start referring to those devices as hazard control devices instead of rapid shutdown devices. The focus is safety and reliability and interface from other devices. We've drawn from other standards, from other lessons learned in different industries. It's going to be very important to understand what's in the installation manuals. This will explain how to interface different devices. Again, using the PVRSE equipment idea, manufacturers will need to explain the ratings of the products, and maybe even provide a list of other products that they are compatible with. And this is to make sure everything works when it's installed. So this avoids something from manufacturer A, somebody in the field grabs something from manufacturer B, but manufacturer B was never really evaluated or looked at, or it wasn't tested together, or perhaps the voltage or the current ratings don't even line up. You put those 2 things together on day 1, it appears everything's okay, and you walk away from the site. Well, guess what? That might not work reliably when it's needed. And so the whole purpose really is just to give a list of compatible equipment when you're going for that. So pay attention to the manuals. They're going to get more complex. And note, all combinations of listed equipment may not be compatible. So be sure to understand what your plan is. If you're going to use a certain vendor for those solutions, make sure that the rapid shutdown box, if you will, is compatible with whatever inverter you're using or whatever initiation device you're using. So the rollout, I think most folks are pretty familiar with this, probably more familiar with their regions than I am. I depend quite a bit on the NFPA website to get this information. So I try to keep tabs on what's going on, and it looks like more and more states have adopted NEC 2017 or are about to adopt NEC 2017. So this is good. Code is changing. There's a lot, not just with rapid shutdown, but with energy storage, electric vehicle charging, home automation, load control, things like that. There's a lot of new stuff going on now electrically. And so the code is evolving to handle that. So it's nice to see that the nation is starting to adopt NEC 2017. The important thing to remember with rapid shutdown is it's, as with any changes in code, it's sometimes hard to predict exactly what's going to happen region by region. Most regions may enforce by the permit date. I've actually called out to a few folks to find out what they're going to do. For example, if you get your permit on December 29th and you go install the system on after New Year's, say on January 10th or something, you got that system permitted under NEC 2014. That's okay. That's how your plans were approved. When the inspector reviews the site, in many cases he may say, okay, realize you did this right before the change, so you're okay. In other regions, that may not be the case. So I talked to some folks in Massachusetts area, for example. They said they plan to inspect on January 1st for the NEC compliance to rapid shutdown, regardless of when the permit was issued. So be sure to know what's going on in your area. Talk to the inspectors, talk to the building departments. Make sure you know exactly when they're going to enforce the stuff so that there's no surprises. All right, Mike, next one.
All right. Thanks, Jason.
All right.
Let you save your voice for a little bit. I know you're kind of recovering.
Thanks.
We're going to shift now and talk a little about rapid shutdown with SolarEdge specifically, and I'll run through this part. First, just kind of an overview of where things are in the market. We'll break this down into residential solutions and commercial solutions. And then in commercial, we'll actually go one step further and kind of break that down a little bit into subsegments. But in the residential space, for the most part, module level power electronics are being used by just about everybody in the industry. And inherent to module level power electronics is the ability to control voltage. For SolarEdge, we have one optimizer to one module in residential applications. So there really isn't going to be too much of a change in the residential market. And that's kind of our expectation is pretty much things are going to move forward as usual. Whatever you're installing, you can move forward with SolarEdge, or if you're using a competitive solution, obviously we want you to look at SolarEdge and consider us as well. But as far as code compliance goes, there's not going to be too much to drive people to change. Where we do see some changes in commercial, and if you look at sort of the landscape of commercial, this is Green Tech Media got renamed Wood Mackenzie. So this is that data set, what you may have referred to previously as Green Tech Media, now being referred to as Wood Mackenzie. So within the commercial market, we have a number of you got the top four solutions, and then you've kind of this other category. SolarEdge is now, for the first half of 2018, the second largest supplier of commercial inverters in the market. But what you'll also notice is that we're the only module level power electronics solution widely available in the commercial market. So for installers who are building systems with SolarEdge, there won't be too much of a change. Where we do see some change, it will be for guys doing commercial installations with string inverters, because that's where this code will affect you the most. This is sort of another view of that. If you look at kind of DC optimized inverters, you could think of that as SolarEdge or a string inverter with an optimizer on it. In residential, you're pretty much okay if you're doing a DC optimized inverter or a microinverter at this point in time. In commercial rooftop, we don't really see many microinverters being deployed, or at least for that Green Tech Media data set. None of the leaders are really in the microinverter space. So you've got DC optimized inverters and string inverters. Commercial rooftop, carport, and ground mount are all going to be somewhat different. And if you go back and you remember what Jason was talking about when they looked at building rapid shutdown into code, what they're trying to do is allow the first responders to create ventilation. And the reason why you need ventilation is because it's a contained space. So like a dwelling, a home, an office building, something that has four walls and a rooftop is a contained space. And that is something that needs to be altered by the first responder to create ventilation. Something that's like a carport, if it's just a straight covering, in general, is not believed to require additional ventilation. The same thing's true kind of with a ground mount. Correct me if I'm wrong on that, Jason, but that's kind of my understanding of why we're seeing three different segmentations in here. Is that pretty much accurate?
Yeah, that's it. And I think the other important thing to remember about ground mount systems and carport systems is those are usually not occupied by people. So a lot of safety and fire code is written around occupied structures. So neither one of those are considered occupied.
Okay. So we do see three sub-segments coming in within the commercial space. The one that will be the most affected by the change in NEC code will be that commercial rooftop space. So in this case, if you're using just string inverters in commercial rooftop applications and you're about to see a code change in January, you'll need to look at some alternate way to meet code. So what we're looking at is, installers of string inverters face the largest shift in challenges. There are a couple different options that you could look at. There have been some solutions talked about where you put a voltage controller into a junction box for a module. This requires module manufacturers to build the module with a different junction box and with different technologies included inside of them. We've heard a lot of buzz about this, but we haven't seen a lot of products coming into the US. So we're interested to hear from you if you're seeing the products, but we have not seen too much in the way of integrated junction box solutions, which leads you to kind of standalone solutions. That would be more like a SolarEdge Power Optimizer or another third-party power optimizer. These products do need to be tested and listed. SolarEdge products we can speak for, they are tested and listed, and all of our inverters are also tested and listed. So if you have, one supplier for an optimizer, one supplier for an inverter, both of them have to have the same listings, and they have to be listed for use as being NEC 2017 compliant. So there might be some additional steps for the products that you're using. Maybe they've done it, maybe they haven't. That's something you'll have to ask them. If you are using SolarEdge, we're going to give you that as part of the product. So you're going to have solutions that are completely NEC compliant, which basically invites folks, if you have been using string inverters on commercial rooftop and you haven't tried SolarEdge, definitely look at the product because it's going to help you get through this transition to code much quicker. We look at this as kind of the easiest path forward at this point in time. Our layout of products, you can kind of see it here. We are getting a variety of products into the market at this point in time. We have single phase inverters, which include EV charging inverters and storage inverters. So we kind of have this whole family of products now available. In every case, whether it's residential or commercial, where we're showing here the Synergy 3-phase inverter that goes up to 100 kilowatts. In every case, you have power optimizers inherent in the system. And that's been our design philosophy from day one, where we have a simplified inverter architecture and also a simplified module level power electronics architecture in the form of a power optimizer, and the two go together as a system. So in every case, you have an optimizer kind of up there with the module level at the rooftop level, and then you have an inverter at the ground level, both of them able to control voltages where required. And that's kind of giving us an advantage in this space. And then, of course, you also have the monitoring platform, which is going to show you how the system is doing. But for the sake of this conversation and what we're talking about here with code compliance, it is important to know that we're going to have ground level control in the form of an inverter and rooftop control, module level control in the form of an optimizer.
Safe installation and maintenance. So if you've probably heard the term safe DC. This is a feature that was trademarked by SolarEdge since the inception of the product. So back in 2006, when the company was founded, the founders started off thinking about an optimizer as the solution. Since that was the kind of the platform since the beginning, why not put some extra features in the optimizer? You've already got a circuit there. You've got the ability to sense different faults. So you can communicate with the inverter. I mean, these are all great features. You might as well load up some other buttons and whistles on there. So one of the things that made the most sense was to come up with this Safe DC feature. But what does Safe DC do? Safe DC essentially monitors the integrity of the circuit. If it sees any changes out of the norm, it'll shut down the circuit. So some of those changes are disconnection, for example. If somebody unplugs the output wire from the optimizer, it instantly ramps its voltage down to 1 volt. So unlike a PV module without an optimizer, if you disconnect it and the sun is shining on that PV module, it's going to be energized. So you've got some voltages and current there. You may even have some string voltage and current connected in series or parallel with other modules. So great idea to go ahead and put this feature into that optimizer that's located in every module, or the structure from that voltage and current, that energy, if you will. That's the basics of Safe DC. So it's good for installation and maintenance. It means when you're handling the connectors and the wires on the output side of the optimizer, you're guaranteed to be at that Safe DC voltage. It also kicks in when there's an arc fault detected. So it just shuts everything down at the module level. If there's a ground fault detected, same thing. If there's a line-to-line fault, for example, between the DC conductors. So we can also shut down when there's excessive temperature at the optimizer. So that's another key thing that triggers the Safe DC. So Safe DC has a much broader application than rapid shutdown, which is why I just wanted to review it real quick. One of the things that it allows for easily is the rapid shutdown function. So, and we'll go through that on the next slide. I think I've just about covered all this. Yes, on the next slide, we'll walk through the functionality real quick. So this is a visual of a fictitious system, if you will. Mike caught me off guard last time. He took out a couple of modules. So it used to be 16, so I got really used to saying 16 modules in series, but it's just looks like it's only 14 modules in series today. This is a typical residential SolarEdge system. So what we'll go ahead and do is turn the system on so it's in the energized state. So on the next slide, you'll see what a system looks like when the sun is shining on the modules and the inverter is operating normally. So each module can deliver, for this example, 300 watts. The optimizer will then take that current and voltage from the module. It will convert it typically to a lower voltage, higher current. That allows us to put everything on a DC bus and control it. It's SolarEdge's key architecture, if you will. So that circuit, the DC circuit after the optimizer, is still a series circuit. So you add up the voltages. So even though the voltage has been optimized to, this example, 28.6 volts, you still have to add those up because they're in series. So you end up with somewhere around 400 volts on a string at 10 amps delivered to the inverter. Definitely a hazardous voltage and current. So what happens when you initiate safe DC? So on the next slide, we'll initiate safe DC. Great. So safe DC is now active. How is it initiated? So it could be initiated in a couple of different ways, but the way that you initiate it for rapid shutdown is you disconnect the AC power from the inverter. So this is called automatic rapid shutdown. You can turn the breaker off. You can turn off the main breaker, or you could turn off a separate AC disconnect if you have a discrete AC disconnect on the system outside of the main panel. What that'll do is de-energize the AC terminals on the inverter. The inverter will sense that. It will invoke safe DC on the DC side. Excuse me, a little bit of a cold here. The way it invokes safe DC on the DC side is there's constantly a communication signal that's going on between the optimizer and the inverter. When that communication signal is absent, the optimizer will shut down or also it would reduce its voltage to 1 volt. Excuse me, getting a little water there. It will reduce its voltage to 1 volt and it will no longer deliver the energy that it was delivering before. It's constantly checking for that keep alive signal. It's saying, inverter, are you there? Are you there? Is everything okay? As soon as it misses a beat, it shuts down. So that's how we invoke safe DC to comply with rapid shutdown. Okay, a couple things to remember on the safe DC voltage. It's 1 volt per optimizer. So in residential cases, that's 1 module per optimizer. So you can simply count up the number of modules in the string, and that's what your safe DC voltage is going to be. So for example, here you can see it for 240 volt. Excuse me for 1 minute. Sorry, the voice is going there. In 3-phase systems, the difference is you may be using a 2-to-1 configuration where you have 2 modules connected either in series or in parallel to 1 optimizer. In that case, you're only going to have about half the number of optimizers. So just remember, for commercial systems, count the number of optimizers to figure out what your safe DC voltage is versus the number of modules. Okay, automatic rapid shutdown, I already talked about that a little bit. This is something that we brought in, I don't know, maybe 2 years ago, I can't quite remember, but we used to initiate rapid shutdown only by turning the rotary disconnect on the inverter. So we had a resistor in the disconnect box. It was brought into the circuit, and that made everything meet the timing requirements for NEC. We improved that technology. We integrated all of that functionality into the inverter board, and now it's just a sensing thing. So we sense the loss of AC just like we would for loss of grid, anti-islanding. Once the inverter determines that the AC has been turned off, it goes ahead and invokes the safe DC. So everything reaches less than 30 volts in less than 30 seconds. Assuming you have 30 optimizers or less, if you put 40 optimizers on there, it's going to be at 40 volts. So just remember that in your commercial designs and residential designs. This really just simplifies the design. You don't have to install, well, first of all, you don't have to go turn the initiator on the inverter, and you don't have to go install a remote rapid shutdown button or anything like that. You can use existing equipment. Most cases, jurisdictions will let you use the breaker in the main panel as long as you've labeled it as this rapid shutdown initiator. In some areas, they want a separate, discrete AC disconnect. So be sure you know what your local building department requires. Yeah, and this also enables mounting the inverter in either outside or inside. If you mount it, say in the Northeast, for example, if you mount it indoors and your main panel is indoors, you may need to put, you'll have to, for NEC 2017, you actually have to put an AC switch outside so that you can initiate rapid shutdown from the outside of the structure.
All right, thanks, Jason.
Thanks, Mike.
Give you a little bit of a break there. Talk a little about our inverter products, so you kind of have an idea of what goes where. So for our single-phase inverters, we have shifted everything over to the new HD Wave platform. And what comes with HD Wave is smaller, lighter weight inverter, 99% CC weighted efficiency. You're also getting a very high DC to AC ratio of 1.55, longer strings, but you're also getting this integrated automatic rapid shutdown that Jason was talking about. So when you're seeing the AC turn off, we're activating a rapid shutdown event. So you're getting less than 30 volts in less than 30 seconds. And then also within the array, you're going to be less than 80 volts within that time limit as well. And so you're ready for NEC 2014 and NEC 2017. The HD Wave technology is available only on single phase inverters at this point in time. So in this case, you have a one-to-one connection, an optimizer per every module. So one of the products that's a little bit different is the StoreEdge platform. So with StoreEdge, we have a DC coupled battery. So you're tying in a battery. LG Chem Resu 10H batteries are the ones that we're currently integrating with. And that battery is going to tie in the same way you tie in solar, which means you're basically using the same low current, high voltage wiring. You're not having to do very thick wires to connect your battery. So that's going to be a high voltage, low current battery connection, and you're going to tie it in the same way as you do the solar, which means that you can also charge it directly from the solar. So any clipping that you would have seen from the inverter will now be channeled directly to the battery, which is a nice advantage there. All of the software is fully integrated, so you're seeing your battery state of charge and your battery status on the monitoring platform the same way you do your solar installation. So that's fully integrated. There's no reason to have a third-party app on your phone or to go from one page to another on your computer screen for maintenance. The system is designed for backup capability. In our research in the US, we found that tends to be the most compelling thing, is that homeowners want power when the grid goes down. And when they have solar, they initially think they're going to have that. It's always a surprise to find out that they don't. But now with batteries and with a StoreEdge device, they can have power for their home from the battery when the grid goes down. Now, the implication of that is that the system is still up and running when the grid goes down. So that trigger that we would normally use for automatic rapid shutdown is that the AC turns off. We're not going to use that trigger to turn the system off in this case because we do want to enable backup power. So that means that there will be a manual rapid shutdown for this product. And this is going to be true for any system that is designed to automatically engage in backup power mode. So in this case, our rapid shutdown activation will be the switch that you can see here. You just turn that to the off position, and then the rapid shutdown is activated. So that's the one difference in our technologies just because of supporting backup mode. Now in the commercial system, want to go through this a little bit. The difference in commercial is you have a 2-to-1 power optimizer or module to power optimizer ratio, which means you've got two modules on a single optimizer, kind of reducing part count in these larger commercial installations. The inverters, we have our Synergy inverters. Those are all automatic rapid shutdown capable, but you will need to pay attention to which optimizer you're putting into which system, depending on your application. Real quick on the Synergy inverter, or actually just any of our inverters in the commercial space. We've got a wide range of power classes, 14 kilowatts all the way up to 43 kilowatts and 208. And the 208 product is one of the higher power class 208 inverters. I think as of the latest webinar we did, it was the highest efficiency in its power class. So if you're looking at a larger scale 208 inverter, which are not very common, this is going to give you that capability. Is Rule 21 capable as well? So you're getting all the latest software, Rule 21 capability, large scale inverter, high efficiency, all on a 208 chassis. On the 480 side, in the Synergy, we've got the ability to go all the way up to 100 kilowatts. We have single inverter units that will give you 30 down to 30 kilowatts. And again, that's all on 480. These all come with the latest in code and utility interconnection requirements, 12-year warranty, and it'll be integrated auto rapid shutdown for our commercial products. So if the commercial building loses power, if the grid goes down, in that case, we're going to initiate a rapid shutdown event. So if you're thinking about, hey, you've got an emergency at a building and the first responders are coming, one of the first things they're going to do is disconnect AC to the building. So that's kind of the reason why we've adopted this philosophy in most cases other than storage. So for commercial buildings, that's going to be in effect as well. So you've got the integrated auto rapid shutdown in that case. On the power optimizer side, so I just want to kind of walk through what this looks like right now. We have in the past had power optimizers that allow you to connect two modules to a single optimizer, and we do that through a series connection. That's our most common application. So what you're going to do in that case, you're going to take two solar modules and you're going to connect them together like you would in a mini string. So you've got module A, module B, you'll connect them together, and then you take the two remaining leads and those go directly into a power optimizer. In many cases, that will still be fine. That'll be a good solution. And so the P730 and the P850 allow you to do ground mount, carport, or NEC 2014 markets. So we're still giving you the outside of the array voltage control with the power optimizer. Upon rapid shutdown, each of these power optimizers reduces the voltage output to 1 volt per optimizer. The reason why we're going to the dual input, and I've got a slide on this in a little bit, is if you look at most 72 cell modules on the market and you temperature correct them to your region, you can get cases where those individual modules are greater than 40 volts. So for example, you have 42 volts on a module once you temperature correct it. When you put those two in series, you add them, and so now you're at 84 and you're above the 80 volt. And without independent control of those modules, you have no way to really lower that. So the P800P and the P860 provide dual input. And so in this case, each module independently connects to the power optimizer. And if you look at the image, you can kind of see what we're talking about there. On the single input, we have a positive and a negative connection. There's just one pair. On the dual input, we actually have two pairs. So there's going to be two positives and two negatives. And so each module directly ports in like that. So between the two, there are different power classes. One of the things to keep in mind is when you're looking at single input, the maximum voltage is not per module, it's per input. So this would be, you're going to add your voltages together in order to get that number. That's why that number is so much higher. As you'd have 60 volts per module. That would be a fairly high voltage, and you can see how that'll pair in. On the dual input, you could kind of read this per module or per input because they're kind of synonymous in this case. So that's one thing I would caution you about when reading the specs is we do list them per input. On the single input, that is a little confusing because the per module is different, but on the dual input, it's the same. So the other difference here in the P800P, so that is supporting 96 cell modules. So mainly that's going to be your Panasonics and your other 5-inch cell providers like SunPower. Those are pretty much the two big ones that we see in the market. The P860 is for basically anything else. So your 60 cell, your 72 cell modules. Now there is a power limit of 860 watts, and that is for both modules. So think of these modules as basically 430 watts each, kind of a max. And then you can see the specs for voltage and current to support the 5-inch cell or the 6-inch cell. All right, so here's kind of an example of what I was talking about, why we're doing things in series in some cases and dual input in other cases, or independent connection in other cases. So, like what I was talking about before, you might have a module where it's 42 volts temperature corrected. So this is not max power point voltage. I understand that would be lower. But when you take voltage and you make the module cold, that voltage goes up. So when you do that temperature correction, you're going to see that voltage go higher than VOC even. And so code has us looking at kind of worst case scenarios in a lot of examples. So we're taking a worst case scenario here. We're going to take VOC and temperature correct it. So you might be seeing something where the voltage of the module goes above 40. And when you add those two in series, you're going to see like what we show here, 84 volts. That's going to be too high if there's a rapid shutdown event initiated on that site. You've got no way to really control that voltage. So we've adopted the product strategy that you see on the right-hand side, independent connection with dual input, where each module has its own connection, its own positive and negative to that single optimizer. And so you kind of get what you see here, where anywhere within the array, you're not seeing anything above that 80 volts. And that's how we kind of control for that.
So listed products. So it's important to understand with any product, you know, they need to be listed for use as rapid shutdown. This applies to the inverter, the rapid shutdown device, whether it's an optimizer or combiner box or some other solution. I think the only thing that doesn't necessarily need to be listed for rapid shutdown is the initiator. It just needs to be a listed device. So any listed breaker or AC disconnect will work. It doesn't need to be a rapid shutdown evaluated breaker, so to speak. The standard there is UL 1741. This is the standard for inverters and power conversion equipment, grid connected equipment. It's a standard we're all very familiar with, those of us that make inverters. The key difference there is that there's a new section that's been added. So the standard can get amended, and new sections are added on. For folks in California, one of the newest additions that we're familiar with is the Supplement A for grid support inverters. And so just like Supplement A, there was another section added for rapid shutdown. And that section contains all the rules and test procedures and product markings and paragraphs you need to put in your manual, et cetera, what you need to do to be evaluated as a rapid shutdown device. So it's key to understand too that there is a change in the code in the way that devices need to be listed. So in NEC 2017, there was a little more flexibility. It just says equipment that performs rapid shutdown shall be listed and identified. So you could take a listed combiner box, some listed contactors, put those together, build a rapid shutdown box, and that's fine. The equipment is listed. You're using stuff that's been evaluated to build that system. NEC 2017, there's a nuance there. It just says the equipment that performs rapid shutdown shall be listed for providing rapid shutdown protection. That means that it needs to be evaluated specifically for rapid shutdown. So there's some harsher tests there. There's conditioning that goes on, there's stress tests, there's high reliability testing that goes on. If you're using software, that software has to be evaluated. So it's a little stricter than it was in NEC 2014. The good news is that the UL standard 1741 was updated with the relevant section to allow those devices to be listed. So any device you're using in NEC 2017 regions, just remember it needs to be listed for providing rapid shutdown. And you can tell by the labeling on the device. You can also tell by the certification documentation. So the device should say, whether it's an inverter or a combiner box or whatever the piece of equipment is, it should be labeled somewhere with either PV rapid shutdown system or it should be labeled PV rapid shutdown equipment. So you can look at the labeling and tell if that equipment has been evaluated. We'll cover lessons learned, and then we'll go into some questions. I see quite a few good questions coming through here. So the lessons we've learned is that in most of the time, the inspectors and firefighters, they recognize the value of the module level shutdown and safe DC. The questions we get aren't so much around, does the system work? Is it a safe thing? I think everybody gets that. The questions are more around the nuances of the initiator, the signage on site, exactly how does the system work? We're curious, things like that. So that's good news. We have heard a lot of feedback from various inspection agencies about the third-party solutions. So again, the ratings of the equipment, the fusing, how it communicates, it's really all around how compatible are those pieces of equipment. Were they designed to be used together? Were they listed to be used together? Do the ratings line up? Just like any other piece of electrical equipment. When you're working with solutions from various vendors, you just have to know that you're putting the pieces together right. And so you have to depend on those manuals. People have to read the manuals, first of all. So that's probably where some of that confusion comes from. It's a solution from a couple different places having to be put together by the installer, and it's not always clearly presented to the inspector. So I would say include all of that paperwork or reference to the manuals or data sheets or whatever in your packages, and just have a clear map and a clear picture to, hey, this is the rapid shutdown solution. It's made up of these three pieces. Here's why they work together. So it's just very easy for them to go down that list and understand it. This was an older thing. I think the commercial string inverters, haven't heard much about that anymore, but with the NEC 2014 compliance, you could essentially, the inverter is a listed device. So you could, on commercial rooftops, and this was a great solution, you could put the inverter next to the array within 10 feet, and you could count on the inverter shutting down when you turn off the AC breaker to de-energize the AC conductors coming from the array. So that works for NEC 2014. It could also work for NEC 2017 if you're handling something else inside that, for the conductors inside that boundary. The nuance there is more around the listing of the product. So NEC 2017 says that equipment has to be listed for providing rapid shutdown. So if you're going to use a solution where the inverter is mounted near the array to control those AC conductors leaving the array, you have to be sure that that inverter says PV rapid shutdown equipment or PV rapid shutdown system on it. You can't just use any listed inverter anymore. So I don't think that that's that big of an issue anymore, but that was some of the feedback that we heard as well. Also check with the local building department and the inspectors about re-roofing or replacing PV system components. I've heard that in some regions, folks are being forced to bring the PV system up to code. So if you had a pre-NEC 2014 PV system without rapid shutdown, you may have to install something to put rapid shutdown on it. Same logic may apply if you had a 2014 compliant system. Again, this is very regional. So make sure you understand what the requirements are in your region. There are, for everyone's information, there are allowances in NEC 2017 to have both types of system existing on one roof, and you have signage that can distinguish the two. So you could have an NEC 2014 compliant on a commercial system, for example, that you might expand. Say the first 100 kilowatts was put in 2014, and then the next 100 kilowatts was put in 2018. You can have a 2014 compliant system and a 2017 compliant system both on the same roof, as long as the signage tells you, and that's spelled out in NEC, as long as that signage tells you which system is which. Now, that's allowances are given in the NEC for that. That doesn't mean that the local building department or inspector won't make you go back and bring that old system back up to code. Hopefully they won't. It's a lot of work, but just be sure that you're aware if that's an issue that we see come up from time to time.
And I think with that, we'll close. Any last comments, Jason? Any questions or things you want to bring up to the audience?
No, this has been a really good webinar. I think lots of great questions here. So thank you everybody for the good information.
Yep, and thank you all for joining us today. And stay tuned for more webinars from SolarEdge.